Welcome to Artificiality, where minds meet machines. We founded Artificiality to help people make sense of artificial intelligence. Every week, we publish essays, podcasts, and research to help you be smarter about AI. Please check out all of Artificiality at www.artificiality.world. We're excited to welcome to the podcast Leslie Valiant, a pioneering computer scientist and Turing Award winner, renowned for his groundbreaking work in machine learning and computational learning theory. In his seminal 1983 paper, Leslie introduced the concept of probably approximately correct, or PAC learning, kickstarting a new era of research into what machines can learn. Now, in his latest book, The Importance of Being Educable, a New Theory of Human Uniqueness, Leslie builds upon his previous work to present a thought-provoking examination of what truly sets human intelligence apart. He introduces the concept of educability, our unparalleled ability as a species to absorb, apply, and share knowledge. Through an interplay of abstract learning algorithms and relatable examples, the book illuminates the fundamental differences between human and machine learning, arguing that while learning is computable, today's AI is still a far cry from human-level educability. Leslie advocates for greater investment in the science of learning and education to better understand and cultivate our species' unique intellectual gifts. In this conversation, we dive deep into the key ideas from The Importance of Being Educable and the profound implications for the future of both human and artificial intelligence. We explore questions like, what are the core components of educability that make human intelligence special? How can we design AI systems to augment rather than replace human learning? Why has the science of education lagged behind other fields, and what role can AI play in accelerating pedagogical research and practice? Should we be concerned about a potential intelligence explosion as machines grow more sophisticated, or are there limits to the power of AI? Let's dive into our conversation with Leslie Valiant. Thank you so much for joining us. We're really excited to talk to you today.
Well, thank you very much for inviting me.
Can you start by telling us what inspired you to write your latest book? We'd be curious to hear that story.
Yes, so I've been working for a long time on trying to understand cognition, both human and machine. And so I've had various theories over the years. And what was always clear is that they weren't complete. They had their various good things about them, but they weren't complete. And so more recently I had this idea, which I think gives the more whole story to what I think cognition is. So I think because I've got some news I was excited about, that's basically why I wrote the book.
Okay, so let's get into that.
Definitely.
What cognition is. But before we do that, we'll go back a little bit to you wrote a book called Probably Approximately Correct, this is a big, it's sort of integrated part of that. Can you explain why it's such a sort of fundamental idea in learning?
Yes, so this so-called PAC learning, probably approximately correct learning, is a model for learning by example. So in some sense, it's a very specialized thing. We see examples of something, like examples of furniture, and we're told whether it's a chair or not. Somehow we and children can figure out in the future when we see something new, whether it's a chair or not. So this is learning by example. It's rather specialized. So what this probably approximately correct model is, it's a model for what you expect a process of doing learning by example to do before you declare it successful. So clearly, you want it to be able to classify future examples with high accuracy, but it's also got this other aspect that you want to put some quantitative constraint on it, that you don't want to spend an infinite amount of effort in learning before you can do well. As you put more and more effort into learning, either computation or more examples, you want the accuracy of predicting the future to get better and better. And also you want it in a kind of a way which is rewarding enough that you're prepared to spend more and more effort. So this is, so essentially modern machine learning is almost entirely based on learning by examples. It manifests this property. And certainly what we see now with large language models, companies spending millions, tens of millions of dollars, hundreds of millions of dollars in training it is a manifestation of this fact that these methods are rewarded for spending more and more effort.
Oh, that makes me wonder, instantly about what happens with rare knowledge, or things that are that are not just rare in the data, but rare in how they appear in larger contexts.
Well, so this is probably approximately correct model. The definition is that you learn from some source of data, and then you will test it on examples from the same source. I mean, these sources could have infinite number of different examples, but you're tested on the same source. So the issue is that if it's very rare in the source of data, you may never see it, and that's why this thing only learns approximately correctly. It'll miss things which are rare, and you wouldn't have had a chance of seeing. So this is the kind of the definition. I mean, if you mean rare in some other sense, then you have to explain what sense you mean it. But this is like a mathematical definition, and it works within the realms in which the assumptions apply.
Oh no, I meant it in the way that you were meaning it. In terms of why what inspired you to sort of develop it further, and how has it influenced the field of computational learning theory over the years? Can we think differently about learning versus intelligence? How do you think about those boundaries?
Well, I think as far as the role of this back learning in theory, so that's been developed by many people, so it's highly developed. So the main effect has been that it also focused the attention of the AI community on machine learning as being the capability which maybe scales up, something we can do well by machine. So people spend a lot of effort in trying management algorithms or management data sets and seeing what works best. In some sense, what we see today is the result of vast amount of empirical effort in trying to figure out exactly what's the best way of doing this learning by example. So I think this kind of stands by itself. I think we understand it reasonably well, and that's what we practice. But then I think as you're alluding to, this is not everything. This is not all of cognition. So then we should ask, what else is there? So you use the word intelligence, which is something which I kind of don't like anymore. So we don't have a good definition of it. So psychologists don't have a good definition. It hasn't helped AI figure out, how to solve things. It's just the word. And I think people who look at human psychology, I don't think find it very helpful either. So I think we have to find other ways of trying to specify what human cognition is. This word somehow doesn't seem to tell us much. So as far as what's missing, I think the thing which is kind of most obvious, I think, to everybody, or maybe everybody who tries out some of these large language models, is that one also needs some sort of reasoning. Humans also chain together pieces of knowledge we have, and this is a different thing from just learning from experience. So this is a kind of a second aspect of this educability as three aspects. This is the second aspect, which I worked also for a long time, and it in this formulation. So the main point is that if you're working in a system like logic or mathematics or physics, which is very has axioms, and you know what exactly the rules are by which you can arrive at a new conclusion, then we know what to do. But in everyday life, things are different because everything we learn is somehow uncertain. So we've got an uncertain way of recognizing whether something is an animal, and a certain way of doing the next thing. And then when we chain together things which are uncertain, what is this reasoning? With reasoning, we assume that we've got some guarantee of some sort that we chain together two pieces of knowledge is still somehow useful to it. So this is an aspect which I call robust logic. It's a way of doing reasoning on uncertain knowledge. So it's it was a second step at trying to extend beyond just learning by example what I think cognition has to cover, basic reasoning.
And I find, I mean, going back to I put intelligence out there just because, you know, I've read what you've said about it, and we entirely agree. It's one of those words that, I mean, not only is the field of psychology and it had difficulty sort of landing it completely, but now that Silicon Valley has got the pen and writing it, it's really sort of dematerialized, and it's sort of a bit of a useless word. But I am really intrigued by trying to understand how educability as a concept and learning from examples, but then being able to generalize beyond those or teach other people and other humans being able to sort of take knowledge from someone else without having to learn it themselves. And the logical reasoning that you were talking about, but also abductive reasoning. So being able to sort of make an intuition. How do you separate all of those threads and describe these things all in ways that are part of human uniqueness compared to other species on the planet?
Yes. So the way I phrase this question of understanding human cognition without having to redo everything about humanity is that the way I ask the question is, you know, what is there special about humans which other species don't have, which enabled us to use the civilization we have? So besides this basic learning and reasoning, which I mentioned, so the third aspect is this idea that we can also teach to others what we've learned ourselves, say, from example. And we can also teach to others what others have taught us. So instead of just having to discover maybe a recipe for doing something, someone can just tell you the recipe, then you know it. You can tell 100 people at the same time, they know it. So this is the third aspect. And then all this takes part also when it's formalized in some sort of notion of a mind's eye, that when we, besides having this memory of everything we know, when we do things, we have some sort of attention mechanism, so we can imagine two or three things in our mind, like maybe two people in front of you and some relationships between them, and we can make a plan what to do next. So all this knowledge we bring to bear on our mind's eye, which is like imagination, working memory, I think, for psychologists. It's in some sense, it's a small space where you represent a few objects, but you can bring the entirety of what you know to it. So you can think up a new plan or a new thought just because you brought together knowledge you didn't have before. So my hypothesis is that, you know, with this, that everything we do, that a large part of what we do is based on these components. That when you think, and maybe you make a metaphor, analogy, we still do it somehow this way, that we have got something in our mind, and we call up some previous knowledge, of which we're reminded by what's in our mind. Okay, so maybe this analogy, metaphor isn't so mysterious. It's just that what we're thinking of is an example of, or close to, something which we already know, but not exactly that.
So
I can tell he's thinking.
Well, I'm stuck on a question, which I realize this is a bit of a rough gear change, but we sort of agree. I definitely agree with you. I'm going back to this concept of intelligence because I agree with you. Last year we were asked to give a talk in Lisbon, and the topic was, are we too obsessed with intelligence, meaning like the word intelligence? And we were sort of in the yes category. But we're stuck in this world now with AI that there's a comparison that people can't seem to stop doing, which is trying to compare the intelligence of humans versus machines, right? That's the whole concept of artificial general intelligence, which is, of course, this concept that is impossible to, if you can't define intelligence, there's no way to define what artificial general intelligence is either. But I'm now wondering how you would respond to someone who says, well, if we're thinking about comparing humans and machines, not on intelligence, but on learning, or on the educability, how would you compare those two?
Well, I think my purpose is that with educability, I'm defining its components in kind of very explicit computational terms. So you should be able to make a machine to do that, modular a few things, and you should be able to test whether a human is capable of it. So it's something you can define. I mean, eventually we'll find out how useful it is. That's yet to be decided. But it's something we can define, and then we can see how well humans do, and we can see how well machines do. So the advantage is that you can define it. And the question is how much of cognition it covers and how well. That we don't know yet. It's a new idea.
How much of that do you think, is there any part of that you'd say we do know today, that you'd be able to compare?
Well, I think the learning by example is clearly, it's got the richest theory, and also of late with the large language models, everyone's impressed how, it can do amazing human-like things. So certainly it does. Of course, what it really is trained for is to predict the next syllable, the next token. That's really what it's trained for. That's all that's promised. And I think, in my view, everything else which it delivers is kind of in our imagination. So if we think it's being, whatever attribute we give to it, I think is in our imagination. But certainly, I think learning by example, we know, is extremely powerful. All the other triumphs of AI, learning to play games better than humans, doing protein structure very, very well. It's all done by learning by examples. But in all cases, it's a very clever way of presenting the data and being clever at what data you present. So learning by examples, we know, is very powerful, and it's also very relevant. It seems very relevant to human cognition because we can do very human-like phenomena, like very smooth prose. Okay, yeah, very smooth prose. So that's the one I'm most confident of. So in some sense, the last of being able to hand on knowledge to other people. So in some sense, that there's something pedestrian about it, because if I have a computer program which works, I can just give it to you, and that's basically all I'm claiming, and it corresponds to very traditional education, which everyone hates, where someone lectures to you, and you're supposed to memorize it. I think that the harder part is how you combine these three aspects in the same system. So here the hypothesis is that we learn by experience, from examples. We can also chain together what we've learned, but somehow we can also, what we've learned in this rich context, I can tell someone else, and then they can put it in their brains. So I think it's more the combination of these three things which is particularly powerful. So separately, certainly this simple reasoning and handing on to other people what you've learned. So separately, there's something very simple about each of the other two separately. The question is whether together, how much it captures what we think of as human cognition.
Yeah, there's I'm just going to grab from the book about, they said, I'm just going to read it because that's the easiest. This suggests that the answer to the age-old question of what uniquely human characteristic is responsible for the creation of civilization, knowledge and culture abound in the non-human world too. The issue at hand here is the cognitive capability that makes possible the creation of knowledge and culture on the vast scale that it occurs in humans. My answer is that this capability is educability, with an integration of the abilities to use symbolic names flexibly to learn from both experience and instruction, and to imply and chain knowledge obtained in both ways. This idea of how flexible, is that part of the sort of computational landscape as well, like how we actually understand just how flexible we are? Like, is creativity a more flexible version of that, or is it a different version of that? How does imagination feature? Because so many words are slightly different. I'm just trying to sort of pull that puzzle together.
Yes. So so as far as these other words, which, if you're asking about other words, the imagination. So I think that's something which takes place in what technically I call the mind's eye. Mm-hmm. So this is where we put things which we're currently thinking about. And if you put together a new combination of things which we've never put together before or no one else has, that's kind of our imagination. So there's a place for imagination. I mean, if you ask me, to discuss the most imaginative humans who ever lived, so that's not where I go. I want to describe, some capability which all of us have. So basically, I want to describe a system which uses the basic ingredients, but it's well integrated. Maybe the word is that it's well integrated. It's not that I've got a copying machine for copying other people's theories, a reasoning machine which does something else, and a learning machine separately. It's all integrated, so I can copy to someone else something I've learned from experience and things like that. Does that make sense?
Yeah, it does. I mean, a lot of sort of understanding the different ways that people are conceiving of, I'm going to say it, intelligence, is, so much of it is grounded in just literally what you say about symbolic, the nature of symbolic and nature of language. So helping people understand the difference between how we're using these different words. Like, for example, in artificial intelligence at the moment, there's a lot of noise around how we have to build, if we want AGI, we have to have world models. And we've got to teach an AI to have a world model, and that's going to have to be something that involves perception and embodied cognition. But it's almost like none of that is talking about the sort of learning that you're talking about in terms of going beyond teaching by example. And I find that kind of curious. It's almost like it's a bit of a blind spot.
Yes. So, so I want to answer the question of how this world model gets there. So in some sense, AI people have some notion of it. So they, some have more notion of it. So certainly, if all the big things they do are learning by example, but they also talk about knowledge graph, which are things like a dictionary, put in an English dictionary of synonyms. So this is knowledge which you're very certain of is accurate, and certainly it's very useful to put in the two words mean the same, because then you can use it somehow. So this is some acknowledgement that that some knowledge will be given by instruction, and not everything will have to be learned. But I try to give a full explanation of how all this knowledge gets in there. Sure. So to get more functionality in the performance of these systems, one needs more knowledge and the effective use of knowledge. Now I should say, so this component of mine, which I talk about chaining together, that's the one aspect of it is also that one can apply knowledge to a particular instance. So if you see something new in your mind's eye, then maybe you apply one thing you've learned to it to reach a conclusion, and then you apply another. So you can apply your knowledge to particular situations in a kind of a novel way, because you string together many things before you really reach your conclusion. So this basic mechanism I've described also is good at applying knowledge to particular situations.
I'm just wondering how would you envisage that in terms of computation?
Well, that's what I call if you do this. You represent this mind's eye, which has objects and relation. So this is more like traditional logic, traditional AI with logic, but the rules you apply to it can be things like neural net, which you've learned. Okay, so there's no restriction of how you represent the knowledge. In particular, you'll represent the knowledge you can in terms of the best way in which you could acquire them by learning. So the components described in the book, they're all computational, so there's no mystery to how you combine them.
Yes, this is the point where I feel like we need the whiteboard. Because it's sort of holding all these ideas in your head at the same time, and it's the limit of my cognition. There's just to go a little bit further into the world side of things, there, and to dig a little bit more into LLMs, because I think it's this constant curious observation on social media at the moment. There's almost sort of two camps. There's those who are LLMs are literally just the representation of the language, forming the statistical representations that and there's absolutely no reasoning. And then there's the camp that's no, there's reasoning here somewhere, and one more like scaling law, and we're going to have some sort of different kind of intelligence pop out. That's sort of the level of what you see grazing LinkedIn on any given 24-hour basis. What's your perspective on this and on scaling laws versus reasoning versus the structure of the graph? What happens when you put multimodal models together? And I'm really curious about how you've seen all of this.
Yeah, so the scaling laws are basically what I was talking about at the beginning, that if you put more and more effort, then you do what you could do before, but more accurately. So scaling laws they make things more accurate, but they don't do something totally different. So my view is that basically all you're doing is predicting the next syllable, but the other aspect of this learning by example is the data set you gave it. So, for example, there's several ways in which these things can do some sort of reasoning, but it's very let's say, random and disorganized. So sometimes you're lucky, it does reasoning, you're impressed, and sometimes it does something which I think is stupid. Mm-hmm. So the kind of instances where it can learn is that if there are if you give it many examples where same kind of reasoning is used, then certainly it picks it up. It picks up that kind of reasoning because it's in very many examples of the reasoning. So the other kind of ways in which you can get some reasoning out is if you really kind of step it in very small steps. So if you wanted to do some mathematical proof, then if you kind of if you spoon feed it exactly, ask you the right questions every step, it kind of unwinds the argument. But it's different from the reasoning we can do, where we're much do holistic reasoning. So I think the whole design of current LLMs doesn't include reasoning except by these implicit ways. One can have other architectures, like what I'm suggesting. So there's a downside to them that they would probably take even more computation, and I'd imagine they'd be more useful in a limited domain. So maybe if you wanted to build a system in a limited domain like medicine, but you really wanted to depend on its recommendations, then that kind of thing would be feasible. Where because you restrict the domain, you're willing to spend more computation, and you're willing to put a bit more effort into the reasoning, so the reasoning is a bit more trustworthy. But I think at the moment, all the reasoning LLMs do is kind of accidental.
That's an interesting observation, because one of the things I've used your book for is to actually get sharper on how I read some of these papers. Like, does it include this kind of? Is it just chain of thought that's been used for this study? I've found that really helpful.
I do love the idea of accidental reasoners. So might quote you on that in the
Sounds
future.
like an 8-year-old.
Yeah, exactly. So can we back up to chaining a little bit, and can you describe what you mean by chaining together knowledge, and what the difference between chaining of knowledge for humans and chaining the chaining that's capable that LLMs currently are capable of? Because we do hear a lot about chain, and that mostly comes through chain of thought. At least broadly, people who are following this space have heard this. But I'm hoping you could define it for us and help differentiate.
Yeah, and I think we're thinking about like the integrated reasoning.
Yeah.
Page 173.
Yeah, but I mean, as far as LLMs, I mean, my understanding of it is that so they certainly give the impression of having a kind of a flow of thought, of having, but that's because they've got this very enormous window. So they're always looking at an enormous window of text, and then when they predict the next syllable, they move one syllable further on. So when they make their predictions, they're very conscious of the past discussion for very, very long in the past. So the fact that they stay on topic sounds human-like and impressive, but it's not, that's not serious. And I don't think that implies any kind of reasoning. So by training and in my system, you instead of just predicting the next syllable in your mind's eye, you've got a little representation of what you're thinking about, with some relation. So maybe you're planning how to travel somewhere tomorrow. So you put in maybe your car as one object, and the weather is another object, and you have a weather prediction, and you put these information together, and then you deduce that maybe where you want to go is too far, you don't want to drive. So you make predictions using your knowledge of what your current information in your mind's eye would predict. And then using that prediction, you can make some further prediction about whether you want to carry forward your plan. So in a large language model, there isn't any explicit way of doing exactly this. So by accident, you can get it, because if the chain you want to reason about are in fact a chain of words, if somehow the argument is laid out linearly for you, then then large language models will do something very similar. But if the reasoning is about concepts which were kind of further back, and clearly the knowledge supports bringing together these two or three things you've thought about in the recent past and what follows from them, that's something which any reasoning system is expected to do. But large language models aren't designed to do that.
Yeah, I find myself thinking that I'm envisioning the chaining sort of physically in my mind, or I have an image in my mind where it becomes a chain, but it doesn't really start as a chain at all. And I guess it's partially my reflection of working together with Helen, and that her mind chains things together in ways that are completely unclear to me, and then she'll pull these things together, and there'll be a chain for her, but I actually have to get her to explain how she's actually created the links in the chain.
When I can't understand how no one sees that chain when it's so clear to me.
But I find it such a useful image, I guess a metaphor when you're thinking of chain, right? But it's such a useful concept because when you embrace the fact that I find we humans chain things together in perhaps unique ways. We all have different things going on in our minds, whereas these mathematical representations that are coming through LLMs, sure, there's a randomness to it. Every time you ask something, you get a different answer. But it doesn't. There's something that I find beautifully mysterious about the way humans chain things.
Yes, so certainly. The fact that we all do it differently is partly because we probably put different things in our mind's eye, what's important to us. Yeah. If you go shopping, maybe one person, the price is very important, another one is the beauty of it is very important, or the usefulness. We all have different preferences, and therefore we choose to put different items in our mind's eye and then chain those. So I think that, of course, we may also have different pieces of knowledge why we chain things differently, but it may just be that we have different interests, and whatever you chain, someone else may not care about.
That makes me. I jump to a conversation we've been having earlier today about whether there's a natural fit or not between people. If you're using Google to search for something that you don't quite know what it is you're searching for, that generative AI summaries could be just a disaster. Because what the LLM thinks is relevant and important to you isn't what's the match in your mind's eye, and you need a bigger return space of options for you to go, oh yeah, that's the one I'm looking for. That's.
I guess I'll flip that to a question, because I'm curious how you'd think about a machine in whatever form, however, whatever software is actually running on it, being helpful to us as we try to chain together our knowledge. Is there a way you can envision how a machine might be helpful to that? Well, I got these two things, but I need something in the middle, or however else you're thinking about creating a chain of knowledge.
Well, the machine may be programmed to be able to do the chaining themselves, but if you think you want it to somehow help you to think through something, I suspect you'd have to kind of prompt it with what you're interested in.
Well, at least that is actually, you can do that.
Yeah.
If it's not a search per se, and it's the model that's more open.
I'm just having this sort of moment thinking about this, in terms of like the process of designing something to be helpful to you, in that part of the the beauty that I was reflecting on before, that we chain things together uniquely, or in unique ways. Therefore, the machine would have to have a pretty decent knowledge about our own unique thought process, and that can be very difficult to communicate. Today we're seeing people use these tools expediently. It's an efficiency, driving sort of process. Whereas, the greatest, I'm going to use this phrase too much, but the greatest chains of knowledge that have come up with generally come through some combination of friction and serendipity. And it just when it happens, and you're like, that works. It isn't something that you can force on a timeline or an efficient way.
Right. So, I mean, another way of saying, maybe you mean something similar, is that so this kind of existing AI is very good when it doesn't matter that much what the answer is. That, if, for example, you're interested in finding a solution to some problem where you're in the bottom 50% of human competence, like, you want to do home repairs and you know nothing about plumbing, then, whatever it tells you, it's probably useful. It's more than what you know, and there may be many other options, but you don't care that much. But certainly if you want something to as you say, to reflect your own personal preferences, or something in which you have high expertise, then the current systems I don't think are quite up to it.
No, I want to ask about on how all of this has made you think about education and about human learning, and about everything from the sort of really high level kind of philosophy of the whole thing. What does it even mean to learn? What's the science of pedagogy? But right down to what it might mean for individual instructors and teachers, and parents, and how they might think about helping, about how they might think about learning differently.
Yes, I've thought about this some, but I think my first level conclusion is being struck by how little we know about education, and how little we sort of study education as a basic science. So we certainly put a lot of effort into education as a best practices endeavor. And so the teachers, people in the education world, we all work hard in using our own experience to make our own teaching better, but how does that relate to anyone else? So it's so I think that the understanding of education is, in my view, is very primitive. So I've been in education for a long time. I hear lots of theories, but it's never clear how transferable they are, how much how much they have general validity. So certainly, I think my first reaction is that we should put more effort into developing some underlying science of education with which we can support people who do education, because I think everyone needs help. So my first answer is that I think this should be the subject of significant research effort. So that's what I've learned from it. So it doesn't give any immediate answers. I don't think. But I think, but certainly, what I've taken from this is that education is very fundamental to who we are. So we should take it even more seriously than we do. It's very fundamental to what we do every day. We educate ourselves every day, even if not formally. When there's the movie, then we're always just soaking up information. We're educating ourselves. So somehow, if we could understand this process better, it would be great. And somehow, whatever we learn should be reflected in improved education. So I think the main moral is, to take education more seriously as a subject of study.
How would you describe what questions, what scientific queries would you have for education?
Well, the most immediate one I raised in the book is, in fact, whether this notion of educability is useful for humans. As I say there, so these IQ tests are a bit strange since we can't define what intelligence is. What on earth is an intelligence quotient test if we don't know what intelligence is? Where did these questions even come from? Who knows? Whereas with educability, there's more of a definition. You could make up tests which test for this. So basically, the basic difference would be that you in the test you'd be tested for knowledge you've gained during the test. So if it's a 1-hour test, you won't be tested for previous skills or for previous knowledge, but for what you've learned during the test. So I think it's a different notion. There's some overlap, of course, with traditional IQ tests, but it's different. So some questions in IQ tests are things like if an apple is to seed, then something is to something. So questions like this, you don't learn anything from this question. It all tests some previous knowledge and previous understanding of relationships. So I think the first question is whether one can develop a good test of educability, and if people are happy that there's the robust concept, then of course the second question is whether are there interventions by which you can improve people's educability. So society somehow could make us learn better, faster, broader, whatever. That would surely be immensely important. So improving education would be a great thing to do, but it's very hard even to ask a question unless you know how to measure something. So educability could be one thing you could measure. That would be my answer.
Why do you think the science is so primitive?
It's primitive in the sense that I want some very basic underlying principles, which I think people have been looking for. Of course, there are enormous efforts in trying to figure out what practices work well in the classroom, how it's transferable from one place to another. So that's all scientific, but I think there's usually no basis to, even if method works very well in one context, and how do you know it's going to work well in a different context? Also, of course, there's serious science done in cognitive science by psychologists, but again, they don't usually ask questions very directly about the education setting. So I think it's a question of asking the right questions. And I think in some sense, computer science has a lot to offer. So maybe one thought would be that in this question of trying to identify what's unique to humans as far as other species, so I think that's been asked for a long time, since Darwin. And I think people probably generally agree that these single word answers like intelligence, consciousness, these things don't quite cut it. So one thing which being a bit more precise, which this computer science allows you to do, is that you can express slightly more complicated ideas. So it may just be that, for identifying what's special about humans, you just need some slightly more complicated idea than a single word you can find in the English language already does. So I think being able to specify these capabilities in computational terms may be very helpful to developing some science-based education.
Yeah, it's interesting when you. I mean, one of the big areas that has benefited, I think, from computer science, from AI, sort of been out there in the wild, is bias and fairness, right? So it's exposed so much, and the whole discussion around that entire area has changed so much in the last 10 years that we've been in AI, simply because we can reason so much more precisely when we have access to this kind of data and the computation associated with it. And I have this sort of this theory that we're on the cusp of that with education, and many other things as well, but specifically education. And we have it. You're not the only person that we've talked to that is almost expresses a little bit of surprise and disappointment that we don't have such a good science around pedagogy, that it is best practices, and the best practices are good and people share, and it's a really healthy community for that. But we're at a conference recently where some of the top people from Google who are designing AI for classroom support, they basically say their job is made hard by the fact that there isn't a good science. And then so you sit there and you say, well, the obvious outcome of that is Google's going to start doing some of the science. And so it's really interesting to think about how the broader cultural response to wanting to understand more about human learning and about educability and about and I think it's only when we start doing that we'll actually value it more. And I think it was Stuart Russell years ago said, when his book came out about human compatible AI, and he made an interesting observation around one of the reasons that teachers aren't paid very well is because we actually don't have a strong scientific, mathematized basis for understanding what it takes to take a little human being and turn them into a thriving adult through a process of education. And I remember him positing that the way that teachers are going to get paid more is when we actually have a set of algorithms that we actually understand, which is such a counterintuitive idea, but I've constantly sort of noodled on it. And part of what your book's done is surfaced that again for me, to really sort of understand that part of how we value these things are when they are less mysterious.
Yes, there's certainly, if there's more of a scientific basis for anything, I think we value the professionals more. So we value doctors because there's a scientific basis for what they do. Yes, I agree entirely with what you're saying about teachers. Yes, I think having a scientific basis for education is good for teaching, and I think good for teachers. But more generally, what you said before, I mean, I do think that computers somehow raise our standards. So, for example, in the fairness area, so clearly computers are doing exactly what humans were doing before. But now, because it's clear what computers are doing, it's easier to be more exacting and saying, well, is this fair or is this not? Whereas for centuries, people were making the same decisions, and no one seemed to care. So yeah, so I think it's yes. So computers do help us raise our game because basically what we ask computers to do is what we were doing before, but we have to be more explicit about what we're doing and why. So it computers hold us to higher standards. And in some sense, the other point you mentioned is that everyone's rushing in saying, well, computers should help in education, AI should help in education. So clearly there's a role, but then, if we don't understand education, what is AI supposed to do exactly for us? But again, the technology is asking the question that, as you say, we should really understand education better, because we can rush in with all these AI tools to change the classroom, but we don't know exactly what to do. So I think it all points to, more understanding of education, I think. Yeah.
So accepting that we would like to have more information and more science, what would you recommend to someone who listens to this and says, I'd like to improve my own educability or my kids? What would you say based on what we know today, or what you think today?
Well, I think my honest answer is that I think these are new notions. I'm honestly recommending that more research be done, and I don't know what the outcome will be. Okay, so the question of whether human educability can be enhanced incredibly, and in 20 years' time we'll all be twice as much as currently useful stuff. I don't know. It could be that educability can only improve so little that it's not worth doing. So I think this is all to be decided in the future. So so I think this would be really novel research to do this, and I don't want to guess the answer. I don't know.
Oh, darn! I was hoping I could get you to guess.
I thought you were going to ask, do you have an experiment you want to run? Like if you could run one experiment and have the answer. You've got a section towards the final part of the book about artificial educability, and we don't normally talk about the singularity and ultra intelligence, but I just thought that this was such a wonderful sentence, talking about intelligence of an intelligence explosion. That sort of idea. And does this argument doom humanity, or is it flawed, referring to a paper from I.J. Good? The argument assumes that intelligence comes in arbitrary, powerful varieties. I believe this assumption is dubious. And there's a lot packed into a few words there. And I'm really interested to understand more about how you think about not everything coming in arbitrary, powerful varieties, and how we should think about the diversity of AI that's been built. How do you think about designing for a particular level of whatever the functionality is, or for a particular level of helping a human do something? How do you pass that? How do you figure that in your own mind? How does that ramble around in that mind's eye?
Yes, so I think it, at one level, that question has got all the same complications as if you were asking about humans. That we are different, we're good at different things, and it's absurd to compare people who do totally different things, saying who's more intelligent. So, as far as computers, one can unpack what the factors are. So, with just learning from examples, the main parameter is what information you feed it with, and different systems which are fed different information will be very different. One may know medical knowledge, another may know about sport, and then it doesn't make sense to compare them. And so this is just the start. So if you put in the other aspects of educability, so one big parameter is that if you've got a standalone system like we are, and we are able to learn from other people, just to transfer their beliefs, then we need a policy to decide, whom do we believe, whose theories do we adopt, and whom theories do we dismiss. And we could have different policies. And so if you imagine robots running around in the world who have different policies for where to get information from, say about politics, you get very different outcomes. And this is, of course, the same, and it just reflects the same situation with humans. So there are so many parameters involved which control what information flows into the system. Who do you believe? What information have you been trained on, if you've been trained? And things like that. So some of this is kind of unpacked a little in the book. And I think this explains why there are many dimensions to these both computer systems and also who we are. That we've had different experiences, we've learned different things, and our brains are filled with different things from each other. So obviously, our form very different in different areas.
Thank you so much for taking the time to talk to us today. It's and I appreciate the fact that you've allowed me to ask a series of questions to which you've said we don't know yet, and we're going to study more. And I hope you hear those with my interest of knowing the answers and a little bit of impatience, because I find it to be such just such an interesting starting point, to really think through this. So thank you so much for the time and patience with those who are still learning here.
Well, thank you very much for inviting me and for all the questions.
Spinning solid state.